Hello, Claire. Welcome to Sweden, first of all. Welcome to the 4th edition of the Data Innovation Summit here in Stockholm. We're very pleased that we finally have GitHub with us.
Very happy to be here.
So before we go on, please introduce yourself, your background.
Sure. So my name is Clair Sullivan, and I'm a machine learning engineer at GitHub, and I've been there since August of 2017. Before that, I was actually a professor at the University of Illinois, and my background is not in machine learning, but it's actually in nuclear engineering. So that's what I taught when I was a professor.
Okay, but that's also part of your expertise, which is getting... Claire, GitHub portfolio, clearly, an advantage. Recent trends in the evaluation of developers, many wonder what employees are looking for what a good GitHub actually account is. What does it mean? A huge usage by all means, very popular, but among many job seekers. So according to your expertise, which job seekers benefit most from these GitHub projects? Also, what makes a good GitHub portfolio?
Well, I can
according
tell you,
to you,
yeah,
the source.
My portfolio is not a good GitHub, so don't base yours based on mine. But I really think that every person who's seeking a job as a developer benefits from having a good GitHub profile for people to look at. And the reason I say that, you can have a resume. Your resume can say you've been a certain type of developer for a certain period of time. But what really matters is that you can show that, you can demonstrate that. And so what a GitHub profile allows a recruiter or a hiring manager to look at is actual demonstration of your ability as a developer. So when people ask me, well, what should I put on my GitHub account to demonstrate things? I tell people that whatever they put there, if you want to demonstrate certain languages, of course you should write in those languages, but not just write in them. You want to think as a recruiter, how do I explain this code that I've written? Documentation is critical here. So don't just provide code, but state what that code does, how it does what it's doing. Provide enough information there for a recruiter or a hiring manager to really say, yeah, this person knows what they're talking about, and they've proved it.
So, to be honest, as we said, nearly every open source project uses at least GitHub to manage it. But you presented today on the machine learning and deep learning track about GitHub and deep learning on graphs of code. A technical type of a presentation, very well received, by the way. Congratulations. You shed light on how can graphs of code be used to obtain information about software and open source development. Could you please share some of the key points from this talk, and what are some of the most appropriate methods for deep learning on such graphs?
Yeah, so deep learning on code it's a hugely interesting, hot research area right now. And one of the things that's just so unique about GitHub is the data set that we have access to in regards to that. And so one of the questions that we asked ourselves with this data set, can we identify duplicate code on the site? And there's research papers out there that show that something like 93% of JavaScript that's hosted on GitHub is actually duplicate. Okay, this is inefficient. It's inefficient for the developers. So if we can identify developers going down a path of creating duplicate code, can we help them write that code? Say, aha, we recognize that you're writing this function that has been written by many other developers in the past. Can we help you with that? Or the ability to help guide a user. Maybe we have a developer who today is a C++ programmer and tomorrow wants to be a Haskell programmer. And we can say, well, we see that you're writing this code that you've already written in C++. Now you're writing it in Haskell. Let us help show you what that looks like as you go with something that is semantically similar, even though syntactically different. So that's kind of the main purpose of what we're looking at. And we were doing this with graphs of code, namely the abstract syntax tree represented as a graph. And then we took it one step further and represented it as an image, because it turned out what we discovered was the more complicated duplicates to detect are easier to detect as an image rather than trying to vectorize a graph, a large graph.
Now, if you allow now, Claire, you already said it, but more like a general type of questions about the latest trends in deep learning. As you said, one of the really the hottest topics, technologies. The market value of deep learning software is projected to grow from 20 million in 2018 to 900 and more, like above $900 million by 2025.
Yeah.
And according to McKinsey, of course. And however, any attempts to discuss both AI and deep learning both in one basket, it's not okay. So we must distinguish between what the first means and what the second. So from an expert point of view, can you please just give your opinion on what is AI, what is deep learning, what is similar, what is different?
Yes. I actually was having this very conversation with a colleague of mine the other day, and I liked how he put it, where he was talking about soft AI or weak AI and strong AI. And you have to say that you have something like an AI entity like Alexa or whatnot. That's a very different thing than I'm using machine learning to fit a bunch of data points. And so you'll frequently see these plots, not even a Venn diagram really, but you've got this big circle that's AI, and then a subset of that is machine learning.
Yeah.
And then a subset of that would be deep learning. And so when I talk about machine learning and deep learning, I'm talking about that weak or that soft AI, not that we're creating robots that are going to have conversations with you and drive your cars for you and all of these things, but just fitting data.
Mm-hmm. So apart from all of these hype, the excitement that has created AI, deep learning applications, on the other hand, still we have to be aware of the challenges that they imply. So according to you, what are some of these challenges that you encounter when it comes to deep learning AI?
Yeah, I think probably most practitioners of machine learning and deep learning would say the biggest challenge is getting labeled data. Mm-hmm. How do I train a model if I don't know what that model is supposed to show? If my model is supposed to say I have a thing and it's either this or it's that, I need to be able to train it on what this looks like and what that looks like. And finding that training data and high quality training data is very complicated. And not only that, but then you have to look at, are you fooling yourself? If I throw something unexpected into my data, does it completely break my model? There's some famous examples of image classification where they say, is this a turtle or is it something else? And then they throw random images in there and it gets very confused. So quality labeled training data to create models that are robust to confuser data, I think is very key.
Claire, 2018 was the year of machine learning at GitHub. According to the 2018 State of the Octaverse report, machine learning and data science projects ranked highly on all kinds of categories. So could you please mention some of these most popular machine learning projects last year?
Sure. By far, looking at the State of the Octaverse, I believe the number 3 repository that people were looking at was TensorFlow. Mm-hmm. We categorize topics for repositories. So, some repository might have a machine learning topic or deep learning topic, conversational AI, and you see these topics trending on GitHub, very much so recently. You see other constructs like Keras and PyTorch, and those are also trending. So we can certainly see the rise in machine learning specifically, but also you can look at things like languages that machine learning is typically written in, Python being the example. And Python right now is the number 3 language on the site. So that's certainly quite a change from the days when everybody was hardcore Java, JavaScript.
I know. One last question, Claire. Where will machine learning go in the near future?
If I knew that, I'd be very rich. I do find
that certainly it's changing.
It is certainly changing. And I find that there are some topic areas that are very much of interest to me, and you're seeing a lot of really great work being done there. IoT.
Oh, yeah.
Certainly, you start talking about creating sensors for everything and anything, and you put them anywhere. Hugely fascinating subject area. I also, I really like some of the machine learning work that's being done in satellite imagery. Trying to understand the globe.
Your past.
It's one of my loves. It's true.
Yeah.
But there's some really great work that's being done in understanding imagery at a planetary scale. You know, what I showed today, 2,000 pixels by 2,000 pixels, that's nothing compared to the entire planet being imaged on an hourly basis. It's a crazy amount of data, and it can tell us some truly fascinating things and solve some really important global problems.
Oh, the future is pixelated. Well, okay, Claire, thank you very much. We are really pleased that we had you with us. Thank you for being part of the data innovation and for accepting to conduct this interview. My pleasure.
Thank you for having me.